I wanted to show you a couple of good resources here for astrophotography planning and education in general. So this book is by the Royal Astronomical Society of Canada, and this is the 2015 version. I think the club is pre-ordering the 2016 version now. So there's just a ton of good stuff in here if you're getting started in the hobby. You know, terminology of symbols, telescope parameters, all that good stuff. I believe there is some astrophotography. Here it is, digital astrophotography on page 91. So there's a brief article on that. Yeah, just a few pages, but so this is a great general reference book, but the main thing I use it for is in the appendices in the back here is a bunch of tables on the deep sky. So deep sky from near to far, that's not so great for what we're doing. Star clusters, open clusters, not very exciting to me from a photography point of view, but maybe you'll like them. I like globular clusters. So here's a table of the globular clusters with the NGC number, their coordinates, and how bright they are, and their size is the main thing I'm interested in. And here's the whole Messier catalog. This is nice because it's broken down into seasons. So if we jump over here to, we're in autumn right now, so here are the Messier objects in the autumn. These are the Messier numbers and the NGC numbers, and then the coordinates, RA, dec, and the magnitude, which is the brightness, and their size in arc minutes. And then there's some notes here about what they are. And see here, M31, they've got a couple exclamation points, meaning that's extra exciting. So those are good. The finest NGC objects, again, by season. So here in the autumn, there's a listing. This is kind of from a visual view, so you have to be careful that some of these things that they find really exciting are really actually small. What was it? The blue snowball here, right, is 12 arc seconds, so that's challenging from an astrophotography point of view. Whereas with visual, you can just kind of keep magging up until you get that large in your field of view. Dark nebula. Those are, dust clouds, and the most famous one is here, Barnard 33, the Horsehead Nebula. I'm sure you've seen photographs of that. That's a fairly easy one to, challenging visually, but easy from a astrophotography point of view. Deep sky challenge objects, deep sky gems, again by season, so the autumn sky. So this is a great reference for finding things to take pictures of if you've got a wider field of view. If you're doing wide field, here's a list of things to take images of. And then if you're traveling to the southern hemisphere, or you're using a remote robotic telescope like itelescope.net from Sighting Springs, then you can take advantage of this to see what's in the southern hemisphere. Galaxies, optically brightest galaxies. Galaxies with proper names. So just a ton of good information for finding stuff. And then let's move into the shade so you can see the iPad. Another one here is that a lot of people like is Sky Safari. So it's daytime now, so plus we're pointed at the ground, so this is not very exciting here. Here I can aim up at the sky. People like this because this is one that you can hold up with the camera and line it up with what you see in the sky. And you can see here, this is, at some point I went in and put in my telescope field of view. But for planning, this is nice because it's got this nice search feature, and you might want to look at tonight's best. Now there's different ways you can sort this list. Right now I have it sorted by altitude, but there's other things. Transit time might be a good one. I think there's brightness, visual magnitude, but right now I have it sorted by altitude. So here's the Helix Nebula, and you get a lot of nice information, and you get a picture, and then over here you've got the specs. So the apparent size again is what we're interested in, and you've got the coordinates. So this is a nice one. There's a free, I believe, or a light version that's inexpensive. This one is the Pro version because at one point I was using it to actually run the mount, which works fine, but the problem is, when you get into astrophotography, you're also going to want to be doing plate solving and auto guiding. So those you need a computer for. So at that point, running the mount from the iPad kind of loses its viability. While we're here, there's another one another app I use on the iPad, Polar Alignment. So this I use for a couple things. It gives you your current GPS coordinates, both in decimal form and in hours, minutes, and seconds. So that's handy for inputting into your planetarium and into EQ Mod or your ASCOM control software. And then this is telling me when I look through my polar scope on my Sirius or Atlas mount, it's telling me where I need to put Polaris on the setting circle to be truly polar aligned. And you can actually turn the camera on your iPhone or iPad and put this up against the polar scope and line things up that way. That's a little too much contortion for me. With astrophotography, you've got the mount set as low as possible to the ground to avoid vibration, and that puts the polar scope low and pointed towards the ground, so it's hard enough to get my eye down there, let alone a camera, and then the iPad or iPhone, and then be able to see that. So what I do is I just kind of eyeball it, fix in my mind where on the circle that Polaris needs to be, and then go in there with my eye and put it in that spot. And we'll learn later with PhD2 how to fine-tune the polar alignment, or do polar alignment even if you can't see Polaris.